Hi, this is pre-calculus notes on basic properties of logarithms. I first of all need you to pause this long enough to get all of this in your notes. And then I want to explain why all of this makes sense. So pause the video, write it all down, and in a few minutes I'm going to start talking again to explain why all of this makes sense. Okay, so let's first take a look at this line, all of these properties, okay? All of those properties on that line say exactly the same thing. That if I'm taking the log of something, that something has to be a positive number, okay? And the reason for that is because if I'm taking a positive base, all right, if I'm taking a positive base, then no matter what the exponent is, whether it's positive or negative, the something over here has to be positive. It has to be greater than 0, all right? And so therefore, if I'm going to take a log, you know, the something over here has to be greater than 0 in order to evaluate it. So the domain becomes the range, and we've discussed that before last week. All right, so that's the first line. All right, now let's take a look at, all right, this right here, log of 1 equals 0, and let's try and think about why is that true, all right? So let's think about what the log of 1 means, all right? The log of 1 means that there is 10 to the power of something, and it gives me 1. So I have to think about, well, what number can I raise 10 to that will give me a 1? And the answer is I can raise 10 to the power of 0 equals 1. So x equals 0. All right. As a matter of fact, any base raised to the power of 0 always equals 1. So that's why this is true and why this is true. Because e to the power of 0 equals 1, and because b to the power of 0 equals 1. All right, so now let's take a look at this. Okay, the log of 10 equals 1. And let's try and think about, well, what does that mean, all right? So I'm going to say, what does the log of 10 mean? Let me erase this here. What is the log of 10? Okay, and so what I'm saying there is that 10 to the power of something equals 10. Okay, and so what is x? Well, 10 to the power of 1 equals 10. So x must be equal to 1. Okay, and again, this and this say the same thing. This one says that e to the power of x equals 1, and so x must be 1. I'm sorry, I was wrong there. Equals e. I'm sorry. So that was e to the power of x equals e, and so x must be 1. And then finally, the one on the right, b to the power of x equals b, and so therefore x must be equal to 1. Sorry, I got tripped up there. All right, so that's it for that line. Okay. All right, now, this line. Okay. All right, so on this line, what I've got is a log and its inverse, which is the exponent. All right, so for log, okay, of 10 to the k, okay? The log base 10 and 10 to the power of something are inverse functions, okay? So whatever the power is the answer, because this part here are inverses of each other, okay? And that's true for all of these. All right, so when I'm taking a look at the natural log of e to the power of something, okay, the natural log's base is e. And so does e have the base of e? They undo each other. So my answer is whatever the exponent is. All right, and that's true for everything on that green line. All right, now the last line. Okay. All right, so for the last line, it's exactly the same as the line before it, only the reverse. Okay, so now I've got a 10 to the power of log base 10. Okay, so this part are inverses of each other. So whatever is in the exponent is the answer. All right, and again, that's true for everything on that blue line. All right, here's some problems that I want to demonstrate with you. With all of these problems, we're just going to rewrite the equation in an exponential form in order to figure out how to solve them. All right, so for problem number 1, all right, I'm just going to, the exponential form of that is 10 to the power of 2 equals x minus 3, all right? And then I'm just trying to get x all by itself, so I'm going to simplify this and then add 3 to both sides. Okay. All right, problem number 2. Natural log is base e, all right? So I've got e to the power of negative 1 equals x plus 4. That's the exponential form. I'm going to simplify the left-hand side, okay, get rid of that negative exponent, and then I'm going to solve for x, so I'm going to subtract 4. Okay, problem 3. All right, so here I've got the base is 27. So exponential form is 27 to the power of 1/3 equals x. All right, so x is already solved for. I just have to simplify the left-hand side. So I've got the cubic root of 27 equals x. And so therefore the cubic root of 27 is 3, so therefore x equals 3. All right, that's it for that video.